If you were to fall into a black hole, what would happen? Would you instantly meet your end, or could something else unfold? It's a fascinating question, but let's first understand what a black hole truly is. It's not a literal hole, and it's not even black. Theoretically, a black hole is a region of space with an incredibly intense gravitational pull. However, because black holes absorb all light that crosses their boundary or event horizon, they appear completely invisible in space, so we've labeled them black. Imagine a gigantic spherical cosmic vacuum with an unstoppable gravitational force. Once anything crosses that event horizon, be it a planet, star, or even light itself, it's pulled toward the center known as the singularity and can never escape. Light, the fastest particle in the universe, can't resist, so as a mere human, I certainly wouldn't be able to. If by some cause or accident I found myself nearing a black hole, my journey would play out something like this. As I fall feet first toward the event horizon, my feet would be closer to the black hole than my head, meaning they'd feel a stronger gravitational pull. This uneven force, known as tidal force, would start stretching me out, similar to being on a medieval torture rack, pulling and elongating my body like taffy in the extreme gravity. My head might even be torn off before I reach the singularity. The singularity is the core of the black hole, where all mass gets crushed into an infinitely dense point. Once past the event horizon, known also as the Schwarzschild radius, named after the scientist who described black holes mathematically, I'd be subject to the singularity's influence. Here, physics as we know it breaks down. All our usual understandings of space and time cease to exist, and Einstein's theories don't work. The singularity defies every known law of physics. It's a place of pure unknowns. If I continued falling, my body would keep stretching lengthwise while shrinking widthwise, drawn toward the singularity. Meanwhile, an observer outside the black hole, like my friend, would see things quite differently. From their perspective, I would appear to slow down, inching ever closer to the event horizon but never quite crossing it. To me, however, everything would be happening in an instant. Now, this scenario applies to the most common black holes, but there are other types with unique properties. For example, if I fell into a charged black hole, also called a Reissner-Nordstrom black hole, or a rotating black hole, things would play out differently. These types have multiple horizons. I would still pass the first event horizon, but once inside, there could be a second one beyond which the singularity actually repels me instead of attracting me. Theoretically, after reaching this second horizon, I might encounter what's known as a white hole, which could push me out into another universe entirely. White holes are essentially the reverse of black holes. Instead of drawing things in, they only eject matter and energy. So, in theory, if you fell into a black hole, you might exit out of a white hole into another universe, a kind of one-way cosmic portal. But of course it's unlikely you'd survive in any recognizable form, probably reduced to a long stream of fundamental particles by the time you reach the other side. This potential connection between black holes and white holes is sometimes called a wormhole, a theoretical bridge between different points in space and time, or even between different universes. However, while we have strong evidence for black holes, wormholes and white holes are still purely theoretical. No one has observed these phenomena, and we lack any real proof that they exist. Even with current technology, capturing an actual image of a black hole is incredibly challenging. For example, the supermassive black hole at the center of our galaxy, with an event horizon roughly 1 million km in radius, would require a telescope nearly the size of Earth itself to photograph clearly. However, scientists are developing new methods to capture indirect images, which is how the famous image of the black hole in galaxy M87 was produced in 2019. In our galaxy alone, about 50 objects exhibit behavior consistent with black holes, including the supermassive black hole suspected to be at the center of our Milky Way. This black hole has a mass of approximately 4.3 million times that of our Sun. Meanwhile, the M87 black hole, located far beyond the Milky Way, has a mass of around 4 billion solar masses, with an event horizon over 1 billion km in radius. The presence of these massive objects in the universe strengthens the case that black holes are real, and they're one of the most mysterious and powerful phenomena in existence. Find us next video.